So I'm going to resume with the video from before where we were able to display a teapot, and now I'm going to make it so that if I press the F key in glut that it saves the frame buffer. So the first thing that I need to do is provide in main a callback for when I press a key. I can see now that it needs to take an unsigned character and sort of two ints, which are going to be the X and Y. So I'll call that function keyboard, and I'll go ahead and create it. Sorry about that. Sorry, these push notifications. Okay, so keyboard, and it was, I believe, an unsigned char key, int X, int Y. And I'm just going to switch based on the key, and if the key is an F, then or I suppose lowercase f, I don't care, then I'm going to do some stuff and then break. I'm going to save the frame buffer. So I'll just say save frame buffer. This function doesn't exist. I'm going to create it, and I'm just going to save it as a frame.ppm. So ppm is a file format which you can open with software like OpenGL, which I'll show you in a second. It's just an image format that's easy to work with. Right. So let's work on that function, save frame buffer. So it'll be a void function, and it'll take a string as an argument called fname, which will be the name of the file. So to save the frame buffer, I need to do two things. Number one, grab the pixels, and then two, write them to file. Right. So in order to grab the pixels, I'm going to use GL read or GL. Just a second. I'm not quite sure why the autocomplete isn't working there. GL read pixels. There we go. GL read pixels. And so in the current Windows frame buffer, I can give it the X, the Y, the width and the height, and I don't know what those are going to be yet. Glut gives me a function to get the current width, so I could say sort of int width and height, and I could set width equal to glut get, and then I can pass these different things I want to get from glut, and one of them is glut. Come on, this should be window width. There we go. And I can do the same thing with height. I can glut get glut window height, and then I can read pixels, and I can pass in width. And if you guys didn't notice it before, I used width twice. It should have been width comma height. And then after that, it expects the format. So I'm going to save this as an image. Most images want unsigned bytes or 8-bit information for red, green, and blue. 0 to 255. So I'm going to say glut unsigned, or not glut, GL unsigned byte as the. Actually, that's the type. The format is how the pixels are kind of laid out, and I want GL RGBA. I shouldn't need a number there. I should just be able to say GL RGBA. There we go. Actually, I don't want GL RGBA. I want GL RGB. Let's see if they've got that. There we go. GL RGB. So there's a bunch of different pixel formats. The numbers after them are the total number of bits in each pixel. By default, it's red is 8, green is 8, blue is 8. So I'm going to be getting it as unsigned bytes. And then I just need to pass an array that's going to hold the pixels, the actual pixels. So it's going to copy the information from the screen buffer into a local array. I don't have a local array yet, so I need to create one. So I'll just do unsigned car buff, and I'll set it equal to null initially. So once I know the width and the height, I know that there's 3 channels per pixel. So I need to set a buff equal to, and it's got to be an unsigned car pointer. I need to cast it to the right type. I need to allocate enough memory to hold all the pixels. So I need width times height times 3 bytes of information. And since I allocate memory, whenever you allocate memory, you need to make sure that at the end you free it. So at some point I'm going to need to free buff. So after this called a GL read pixels, the frame buffer information will have been kind of copied into buff. The first row, the first width times 3 bytes will be the first row of the image. So buff 0 is going to be the red component of the first pixel. Buff 1 is going to be the green component of the first pixel, and buff 2 will be the blue component of the first pixel in the, I forget whether it's bottom left, I think it's going to be the top left corner of the image. So, and then buff 3 is going to be the red component of the pixel immediately to the right of the previous one. So it goes row by row, column by column, just like when you're writing text out. And so I've actually got the raw pixel data. Now, before I leave this function, I need to write it out to a file. So I'm going to have to get a file pointer. And I'm just going to, because of lack of creativity, call it F. And in here, I need to open the file using the fopen function. And I've got the file name passed in. And I'm going to be writing to it, and I'm going to write binary data. So I need to write WB. I need to tell it that it's binary because that controls the way that the operating system marks the end of the file. And when I'm done with it, I need to say fclose F to indicate that the file is available, or is no longer needed by my program. We're going to write in ppm format. So you can look up the format online. I'm just going to start showing you how it works. So we need to print a header to the file. So we're going to print it to F, and it needs to start with P6, which is the sort of the magic number that goes at the beginning of the file that tells you that this is in fact a ppm formatted file. Here we go. I'm pulling up a web page here that has the information. So a magic number identifying the file type, and for ppm the magic number is P6. So that's how you can look at the text and figure out that it's supposed to be a ppm image. And you can have new line. Then I need to give it the width and some white space, the height, some white space, the max color value. Really, that needs to tell you the number of bits per pixel. In our case, this is going to be 255. I know it's kind of counterintuitive, but we want to put 255 there. A new line, and then I output the pixels. So each pixel is a triplet of red, green, and blue in that order. It's in binary, and that's kind of already the way that it's laid out in my buffer. The only catch is I think that in my buffer it's laid out upside down from the way ppm wants it. So if I say ppx, I really want to put a new line after that, so p6, and then I'm going to printf to the file f, and I want to print the width, so %d, and then a space and %d, so there's 2 decimals, and I want to print the width and the height. And then on the next line, oh, sorry, this needs to be followed up with a new line. Then on the next line, I need to print to F the max number of colors used, 255, because we're doing unsigned bytes. And then I need a new line. And then I need to write out the pixels. And I'm just going to go ahead and write them all out, and we'll see, I believe the image is going to show up upside down. But I can use F, I believe it's right, and I can pass in buff, and the size of each thing I write, so it's just going to be 1 byte, and how much I want to write, width times height times 3, and that it's going to go to the file F. So that'll put all the pixels out, and when I'm done I can close the file. And let's see how this works. I know that was a lot to do before running, so let's give it a shot. Here we run. And I had an error right here because I misspelled height. Kudos to you if you caught it. Let's build it. Here we go. Pixels is undefined because I called it buff for buffer. Let's build it again. Kudos to you if you noticed that. Now no more errors. And if I run it, here's my teapot, and I'm going to press the F key, and I'm going to try to open the Explorer window where my program was, and I see here a file called frame.ppm. And if I open that ppm file with IrfanView, which you can download off of the internet, we see here the pot, convenient, like I predicted, it's stored upside down. And that's just a difference between, I think OpenGL gives it to me with 0, 0 at the upper left, but ppms expect 0 to be on the lower left, or something like that. We're going to have to look that up. So there's all these kind of little caveats you have to get straight. In order to fix that, instead of just writing the entire buffer at once, and I'm going to say for int y equals height minus 1. Can't do it like that because this is C. I need to declare int y at the top. So I'll set y equal to height minus 1, and I'll say while y is greater than or equal to 0, I'm going to decrement y. And I need to figure out where in buff is the offset for that row. So each row is going to have width times 3 bytes of information that needs to be sent, and the row is going to start at buff plus y times width times 3, because there's width times 3 things in a row. That's how big a row is, and I need to move down to the y-th row, so each step is going to be kind of width times 3. So now if I run this, if it compiles, it doesn't compile because the program is still running, but now if I compile it, it compiles, and if I run it, here's my image. I hit the F key, and I open it up in the Explorer, and I open up frame.ppm, and here the thing is sitting there right side up. So I guess that's a lab. Sorry, the video is 13 minutes long.